maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience.
Everyone, welcome back to our Microsoft Azure Data Fundamentals Virtual Training Day. This is part 2 of the course Azure Data Fundamentals. In this section, we will start with Module 4, Explore Fundamentals of Large-Scale Data Warehousing. Then Module 5, Explore Fundamentals of Real-Time Analytics. Finally, we wrap up with Module 6, Explore Fundamentals of Data Visualization. This module talks about the large-scale data warehousing, where we'll first look at what is large-scale data warehousing, then we'll cover the data ingestion process, later exploring some analytical data stores and how to choose the right service that you need. What is large-scale data warehousing? Large-scale data warehousing is a generic term that describes the infrastructure and processes used to support large-scale data analytics. Large-scale data warehousing solutions combine conventional data warehousing used to support business intelligence. It involves copying data from transactional data stores into a relational database with a schema that's optimized for querying and building multidimensional models, with techniques used for the so-called big data analytics, in which large volumes of data in multiple formats are batch loaded or captured in real-time streams and stored in a data lake from which distributed processing engines like Apache Spark are used to process the data at scale. Large-scale data warehousing architecture can vary, as can the specific technologies used to implement it. But in general, the following components are included: data ingestion and processing. Data from one or more transactional data stores, files, real-time streams, or other sources is loaded into a data lake or a relational data warehouse. I repeat, during data ingestion process, the data from one or more transactional data stores, files, real-time streams, or other sources is loaded into a data lake. The load operation usually involves an ETL or ELT process. What is ETL and ELT? Well, ETL is extract, transform, and load. And ELT, on the other hand, is extract, load, and transform. It's a process in which the data is cleaned, filtered, and restructured for analysis. In ETL process, the data is transformed before being loaded into the analytical store, while on the other hand, in ELT process, it's the reverse. The data is copied to the store first and then transformed. Either way, the resulting data structure is optimized for analytical queries. Where ETL is the traditional method, ELT is a fairly newer one and a faster one. The data processing is often performed by distributed systems that can process high volumes of data in parallel using multi-node clusters. Data ingestion includes both batch processing of static data and real-time processing of the streaming data. Then is your analytical data store. The data stores for large-scale analytics includes the relational data warehouses, file system-based data lakes, and hybrid architectures that combines the features of the data warehouse and the data lakes. And you might have heard of the terms, or probably these are new ones, data lake houses or lake databases. We'll discuss this in a little more depth later on. Then is your analytical model. while data analysts and data scientists can work with the data directly in the analytical data store that we just talked about, it is common to create one or more data models that pre-aggregate the data so that it's easier to produce reports, dashboards, and interactive visualizations. Often these data models are described as cubes, which is the third part in the pipeline, in which numeric data values are aggregated across one or more dimensions. For example, to determine the total sales by product and region, the model encapsulates the relationships between data values and dimensional entities to support the drill up and drill down analysis. Next, the last part of the pipeline is the data visualization. Now, all the data until now that is getting ingested in the data store, aggregated in the cube, will now be used to generate meaningful reports, dashboards, and other visualizations. The data analysts are consuming this data from analytical models and sometimes directly from analytical stores to create these reports, dashboards, and other visualizations. Additionally, users in an organization who may not be technology professionals might perform self-service data analysis and reporting. The visualizations from the data show trends, comparisons, KPIs, the key performance indicators for a business or other organization, and can take the form of a printed reports, graphs, and charts in your documents, your PowerPoint presentations, web-based dashboards, and interactive environments in which the users can explore the data visually. Pretty interesting four-stepped pipeline that we see on the screen. Now that we understand a little about the architecture of what is a large-scale data warehousing solution looks like as a pipeline, some of the distributed processing technologies that can be used to handle large volumes of data, it's time to explore how data is ingested into an analytical data store from one or more sources. On Azure, large-scale data ingestion is best implemented by creating pipelines that orchestrate ETL processes. You can create and run pipelines using Azure Data Factory, or you can use the same pipeline engine in Azure Synapse Analytics. If you want to manage all of the components of your data warehousing solution in a unified workspace. In both of the cases, the pipelines consist of one or more activities that will operate on the data. An input data set provides the source data, and activities can be defined as a data flow that incrementally manipulates the data until there's an output data set which is produced. The pipeline uses linked services to load and process data that enables you to use the right technology for each step in the workflow. For example, you might use an Azure Blob Store from the storage account linked service to ingest the input data set. Because data is ingested through the Azure Blob Store, it is called the linked service here. And then we use services such as Azure SQL to run a stored procedure that looks up related data values before running a data processing task on Azure Databricks or Azure HD Insight, or apply a custom logic using an Azure function, as you see on the screen. Finally, you can save the output dataset in another linked service, such as Azure Synapse Analytics. Note that pipelines can support some built-in activities like copying data, which do not require any linked service. Moving on, as we previously discussed, there are three common ways to implement an analytical data store: a data warehouse, a data lake, or a hybrid solution. A data warehouse is a relational database in which the data is stored in a schema that is optimized for data analytics rather than transactional workloads. Commonly, the data from a transactional store is denormalized into a schema in which numeric values are stored in a central fact table, which are then related to one or more dimension tables that represent entities by which the data can be aggregated. For example, a fact table might contain sales order data, which can be aggregated by customer, product, store, and time dimensions, enabling you to easily find monthly total sales revenue by the product for each store. This kind of fact and dimension table schema, we call it a star schema because we're having the fact table in the center and then the dimensions. Though it is often extended into a snowflake schema by adding additional tables related to the dimension to represent dimensional hierarchies. For example, the product might be related to product categories. A data warehouse is a great choice where you have transactional data that can be organized into a structured schema of tables. And you want to use SQL to query them. A data lake is a file store, usually on a distributed file system for high performance data access. Technologies like Spark or Hadoop are often used to process queries on the stored files and return data for reporting and analytics. These systems often apply a schema on read approach to define tabular schemas on semi-structured data. Files at the point where the data is read for analysis without applying any constraints when it is stored. Data lakes, on the other hand, are great for supporting a mix of structured, semi-structured, and even unstructured data that you want to analyze without the need for schema enforcement when the data is written to the store. You can also use a hybrid approach that combines the features of data lake and data warehouse in a lake database or a data lake house. The raw data is stored in files in a data lake, and a relational storage layer abstracts the underlying files and exposes them as tables, which can be queried using SQL. So basically, you get best of both the worlds. Synapse Analytics also supports a lake database approach in which you can use database templates to define the relational schema of your data warehouse while storing the underlying data in the data lake storage, separating the storage and compute for your data warehousing solution. Data lake houses are a relatively new approach in Spark-based systems and are enabled through technologies like Delta Lake, which adds relational storage capabilities to Spark. So you can define tables that enforce schemas and transactional consistency, support batch-loaded and streaming data sources, and provide SQL API for querying. All these services are meant to hold the data for analytics. Depending on the demand, you might think, how do we choose a data store out of all these things that we have talked about? So on Azure, there are three main services that you can use to implement a large-scale analytical store: the Azure Synapse Analytics, Azure Databricks, Azure HD Insight. Each of them has their own features and highlights, and we're going to talk about them, and then you can make a call of what is best for you. Azure Synapse Analytics, it is a unified end-to-end solution for large-scale data analytics. It brings together a number of technologies and capabilities, enabling you to combine the data integrity and reliability of a scalable, high-performance SQL server-based relational data warehouse with the flexibility of a data lake and an open-source Apache Spark. It also includes native support for log and telemetry analytics with Azure Synapse Data Explorer pools, as well as built-in data pipelines for data ingestion and transformation. All Azure Synapse Analytics services can be managed through a single interactive user interface. It's called Azure Synapse Studio, which includes the ability to create interactive notebooks in which Spark code and Markdown content can be combined. Synapse Analytics is a great choice when you want to create a single unified analytics solution on Azure. On the other hand, in the middle of this slide, you see Azure Databricks, which is an Azure implementation of the popular Databricks platform. Databricks is a comprehensive data analytics solution which is built on Apache Spark, which offers native SQL capabilities as well as workload optimized Spark runtimes for data analytics and data science. And it is an interactive user interface through which the system can be managed and data can be explored in interactive notebooks. Due to its common use on multiple cloud platforms, you might want to consider using Azure Databricks as your analytical store if you want to leverage existing expertise with the platform, or if you need to operate a multi-cloud environment or support a cloud portable solution. Then we have Azure HD Insights, which is an Azure service that supports multiple open source data analytical cluster types. Although not as user-friendly as Azure Synapse Analytics and Azure Databricks, it can be a suitable option if your analytics solution relies on multiple open source frameworks like Hadoop, Spark, Kafka, Storm, HBase, or if you need to migrate an existing on-premises Hadoop-based solution to the cloud. Time for a demo where we will provision Azure Synapse Analytics workspace in your Azure subscription and use it to ingest and query data. All right, so let's get started. This is the Azure portal homepage. Select Create a Resource. Search for the Azure Synapse Analytics workspace preview. Click on Create. Give your subscription name, resource group name. Now, if you're using the MS Learn sandbox, you should have the resource group and subscription already, saying concierge subscription and a Learn resource group. So you can choose those. Otherwise, if you have your own subscription, just simply create a new resource group, give it a name and click OK. We are creating a resource group because we want to delete all these resources later on. So if you delete the resource group, every resource as a part of this group will be automatically deleted. I already have one resource group going on. Give a name to your managed resource group. Give a unique workspace name. Let's just give it synapse-workspace-demo. All right, it's available. Region, select any of the suggested regions. Then you have to create a data lake generation to storage. We already have it from our subscription from part 1. I'll just simply select my account and the file share. You can create a new file share. Just give it a name and click OK. Review and create. And when we click on the create, it will simply deploy the workspace. It might take 5 to 7, 8 minutes for the deployment to happen. So just to save this time, I've already created one resource for ourselves. I'll just go back to this one, the home page. I'll open my Synapse workspace, which is called Synapse WS MBTD. On the overview page, if you observe, there's the Open Synapse Studio. So you can build your solutions in this studio. Click on Open, and this would open your Azure Synapse Analytics Studio in a new tab. This is a web-based interface that we can use to work with the Synapse Analytics workspace. On the left-hand side, if we expand this icon, these are all the pages to work with. So home, data, develop, integrate, monitor, manage. We'll be using most of these in this demo. The first thing what we want to do is to ingest some data. When you click on ingest, these are the copy data tool steps that we have to perform. So from properties, we will select a built-in copy task. We just want to run it once for now. Click next. In the source step, let it be all. For a connection, create a new connection. In the files, you will see a linked service called HTTP. Select this and click on continue. Now you have to give it a name. Let it be the default one. You can give your own name, like say Adventure Works. Description, this is a product list via HTTP. Connection via auto resolve integration runtime is fine. Give the base URL as, I have a CSV file as the base URL, so I'm giving a GitHub link for it. Server certification we are enabling. Authentication type will go with the anonymous. Then after creating this connection, we'll move on to our next step. This won't take a lot of time. The next step is our source data. So in this, let's just do this relative URL, just leave it blank. We want to go with the get method. We don't need these details, so leave it like that. Click on next. Let's preview some data. Now if you see from the link that I've given as the base URL, this is some data which is coming and it will be ingested to the analytics tool, right? Close this. Select the file format as delimited, comma is fine. Select a row delimiter. We'll do a /n. I hope you remember the delimited files that we discussed. Compression type none. Next. Then you have your destination. Where you want to select your Azure Data Lake storage. Workspace. That we have all, that this has been already created when we created the Synapse workspace, right? Now we'll browse the folder path. This should be the file system, the file share that we created in the storage account, right? Give the file name as products.csv, because we are using a comma separated value file. Copy behavior none, maximum current concurrent connections no, leave all this blank. Next, we'll see the file format, delimited text is fine, comma, line feed, /n. We want to add the header to the file. We don't want any compression, rest of the things are fine. Let's click on next. These are the settings that you would have to provide. Task name could be anything. Describe what are we doing. We are copying the products data. Rest of the things are fine. Next, review and finish. These are all the details that were filled up. This will create the database pipelines and it will copy all the data once this deployment is finished. Wouldn't take a lot of time. Just click on finish and you're done. Now, going back to the Synapse Studio, we'll select the monitor page. Here we will see that the pipeline has already run. One pipeline is succeeded. The other pipeline to copy data is still in progress. Now, if you refresh, you would see the current status of your pipeline. Click on this pipeline that we have just created. Now, on the data page, we'll select the linked tab. Here, we will see the Azure Data Lake Storage Gen 2 hierarchy, and we'll find our Synapse workspace. Now, if you notice, this file share has been copied with the file product.csv, right? So this is your data ingestion. And this is a pipeline that has been created. We have put some data from the data lake to Synapse Analytics workspace. Now, the next we will see how to use SQL pool to analyze your data. Now, because we have ingested some data into the workspace, we'll now query it. In this same panel, we'll just click on the product.csv, right click, select your SQL script, select the first top 100 rows, and you will see a default query generated. So open row set, format CSV. If you run this, this would bring all the data in the result like this. Now, it was quick, but it might take some time when you're doing it for the first time, right? Just make sure in the connect to, we have selected the built-in. This will represent that the built-in SQL pool was created with the workspace. Now, if you observe that the resultant table, it has the C1, C2, C3 as the header columns, right? Now, if you want to see this without the headers, the only result table, what we'll have to do is just simply add header row as true. Now look at the results. That first header row is gone. So you can modify the queries and we can replace these data lake file and the Synapse file. However, whatever you want to look at, whichever file share you want to explore, you can just put it and explore using this query. Now in the properties pane towards the right, this is the script name. We'll just change it to count products. And we publish this file. So this script will be published and we can reuse it again whenever required. If you rerun the query, this is your table named count products. Now, if you move to the results pane, let's just check the chart view. And here are the things that you can change. If you want to see the category column by product name, and you can change these values. So this chart will show you a resultant of what do you wish to see from that data that is ingested. So this is kind of analysis that you can do on the Synapse with the SQL pool. Now we will use a Spark pool to analyze the data. Now we know that SQL is the common language for querying the structured data sets. Many data analysts also use languages like Python. And in this Synapse Analytics tool, you can run Python code in the Spark pool. Let us go and select the Manage page, select the Apache Spark pools, create a new one, give it a name, memory optimized. We'll choose a small 4 cores, auto scaling be enabled, number of nodes minimum and maximum 3 should be enough. Review the settings and just create the Spark pool. I already have one Spark pool created, so let's just look in. Once we move to the data page, we'll see the file system that we have created. We'll right click on the product.csv, click on the new notebook, click on load to data frame. Okay. In the attach to, just select the Spark tool to create the previously created one, and make sure the language that is being used is Python. Review the code, what it shows, and simply run it. When you run it, it will come up with all the data in the table, including the headers C0, C1, C2, C3. It's the same list, it's just a different view in a different language. Just as we use the SQL, we can also use the Spark pool to query and analyze the data. Okay. Similarly, we did with that, we can remove the comment and do it without the headers. Once it'll return the table, right? You can scroll down and give another code. I have it pasted with me, so I'll just simply run this. We are just grouping the count by the category name. Okay, so you will see this result, which is similar to what we found, and you can also see the chart view of this table that we have just queried. Close the notebook. You can, explore as much as you want in this. Simply close it when you're done. Stop the session, discard all your changes, and delete the Azure resources that you have created in the resource group. How to do that? Just simply go back to your portal, look for resource groups, go to your resource group and click delete resource group. That's all you have to do. Okay? Perfect, that was it. So what all did we cover? We talked about creating Azure Synapse Analytics workspace. We also learned how to ingest data, create a pipeline, bring data from the data lake, storage. We also created SQL pool to analyze the data. Similarly, we analyze the data using the Spark pool. So it's a combination of all these services, one stop that you can use with the Azure Synapse Analytics. I hope this was helpful. Let's move on. That brings us to an end of our module 4. Let's see what all we learned. We started off understanding large-scale data warehousing, understanding the data ingestion process through ETL and ELT, denormalizing relational data in the analytical data store, data modeling in cubes, to data visualization. We'll discuss more of these terms later. Then we discussed data ingestion pipelines with types of analytical data stores and how can you choose the best option for yourself. This concludes module 4. We will now take a quick 10 minutes break and start back with our module 5, explore fundamentals of large-scale data warehousing. See you there. welcome back from the break. This is Microsoft Azure Data Fundamentals Virtual Training Day Part 2. And we are at the Module 5 of our course, Explore Fundamentals of Real-Time Analytics, where we will understand what is streaming, batch versus real-time streaming, and service in Azure that does real-time stream analysis. Let's proceed to our lesson, Streaming and Real-Time Analytics. This module is designed to present a conceptual overview of real-time processing and describe Azure services that can be used to single operation. Then we have stream processing towards the right, in which a source of data is constantly monitored and processed in real time as new data event occurs. In batch processing, nearly arriving data elements are collected and stored, and the whole group is processed together as a batch. Exactly when each group is processed can be determined in a number of ways. For example, you can process data based on a scheduled time interval, like maybe every hour, or it could be triggered when a certain amount of data has arrived, or as a result of some other event. For example, suppose you want to analyze the road traffic by counting the number of cars on the stretch of road. A batch processing approach to this would require that you collect all the cars in the parking lot and then count them in a single operation while they are at rest. If the road is busy with a large number of cars driving along at frequent intervals, this approach may be impractical. And note that you don't get any results until you have parked a batch of cars and counted them. A real-world example of batch processing is the way that credit card companies handle billing. The customer doesn't receive a bill for each separate credit card purchase, but we get a monthly bill for all of that month's purchase. Advantages of batch processing will be large volumes of data can be processed at a convenient time. It can also be scheduled to run on a time when computer or system might otherwise be idle, such as overnight or during your off-peak hours. The disadvantages of batch processing will include the timely delay between ingesting the data and getting the results. All of a batch job's input data must be ready before a batch can be processed. This means data must be carefully checked. Problems with data, errors, and program crashes that occur during batch jobs bring the whole process to halt. The input data must be carefully checked before the job can be even run again. Even the minor data errors can prevent a batch job from running. Understand stream processing in the other way, in which each new piece of data is processed when it arrives. Unlike the batch processing, there is no waiting until the next batch processing interval. Data is processed as individual units in real time, rather than being processed at batch at a time. Stream data processing is beneficial in scenarios where new dynamic data is generated on a continuous basis. For example, a better approach to our hypothetical car counting problem might be to apply a streaming approach by counting the cars in real time as they pass. In this approach, you don't need to wait until all of the cars have parked to start processing them. And you can aggregate the data over time intervals, for example, by counting the number of cars that pass each minute. Real-world examples of streaming data includes a financial institution, which tracks changes in the stock market in real time, computes values at risk, and automatically rebalances the portfolio based on stock price movements. Also, an online gaming company collects the real-time data about the players, game interactions, and feeds that the data into the gaming platform there is. It then analyzes the data in real time, offer incentives and dynamic experiences to engage its players. One more example can be a real estate website that tracks a subset of data from mobile devices and makes real-time property recommendations of properties to visit based on their geolocation. Stream processing is ideal for time-critical operations that require instant real-time process. For example, a system that monitors a building for smoke and heat needs to trigger alarms and unlock the doors to allow residents to escape immediately in the event of a fire. Understand the differences between the batch and stream data. Apart from the way in which the batch processing and stream processing handle data, there are other differences too, like the data scope for both of them is different. Batch processing can process all the data in the data set, while stream processing typically only has access to the most recent data received, or with a rolling time window, the last 30 seconds like. Also, the data size for batch processing is suitable for handling large data sets efficiently, while stream processing is intended for individual records or micro batches consisting of very few records. Both of them also vary in their performance. The latency for batch processing is typically a few hours. Stream processing typically occurs very immediately with latency in the order of seconds or sometimes milliseconds. And you typically use batch processing to perform complex analytics. Stream processing is used for simple response functions, aggregates, or calculations such as rolling averages. These were some of the differences, but you can also combine batch and stream processing. Many large-scale analytics solution includes a mix of batch and stream processing, enabling both historical and real-time data analysis. It's very common for stream processing solutions to capture the real-time data, process it by filtering or aggregating it, and present it through real-time dashboards and visualizations. For example, showing the running total number of cars that have passed along a road within the current year, while also persisting the processed results in a data store for historical analysis. Alongside batch process data, for example, to enable analysis of traffic volumes over the past year, even when real-time analysis or visualization of data is not required, streaming technologies are often used to capture real-time data and store it in the data store for subsequent batch processing. This is equivalent of redirecting all of the cars that travel along a road into a parking lot before counting them. Now let's look at a service which will tell us the real-time analysis. Microsoft Azure supports multiple technologies that you can use to implement real-time analysis of streaming data, including Azure Stream Analytics. It is one of the PaaS solutions, the platform as a service solutions, that you can use to define streaming jobs that ingest data from the streaming source, apply a perpetual query, and write the results to the output. Azure Stream Analytics is a service for complex event processing and analysis of stream data. Stream Analytics is used to ingest data from an input, such as Azure Event Hub, Azure IoT Hub, Azure Storage Blob Containers, and process the data by using a query to select, project, and aggregate data values. Write the results to an output, such as Azure Data Lake Generation 2, Azure SQL Database, Azure Synapse Analytics, Azure Functions, Event Hub, or even Microsoft Power BI. Once started, a stream analytics query will run perpetually, processing new data as it arrives in the input and storing all the results in the output. The easiest way to use Azure Stream Analytics is to create a Stream Analytics job in the Azure subscription, configure its inputs and outputs, and define the query that the job will use to process that data. The query is expressed using SQL, the structured query language syntax, and can incorporate static reference data from multiple data sources to supply lookup values that can be combined with the streaming data ingested from an input. If your stream process requirements are complex or resource intensive, you can create a stream analysis cluster, which uses the same underlying process engine as the stream analytics job, but in a dedicated tenant. So your processing is not affected by other customers, and with configurable scalability that enables you to define the right balance of throughput and cost for your specific scenarios. There are many services that can ingest data for streaming processing on Azure. One is Azure Event Hubs, which is a data ingestion service that you can use to manage queues of event data, ensuring that each event is processed in order exactly once. Then you have Azure IoT Hubs, a data ingestion service which is similar to the Azure Event Hubs, but it is optimized for managing event data from IoT devices. Then you have Azure Data Lake Storage, which is a highly scalable storage service that is often used in batch processing scenarios, but it can also be used as a source of streaming data. You also can use it with Apache Kafka, which is an open source data ingestion solution and is commonly used together with Apache Spark. You can use HD Insight to create a Kafka cluster, sinks for stream processing. The output from stream processing is often sent to the services like Azure Event Hubs, which is used to queue the process data for further downstream processing. It can also go to Azure Data Lake Store or Azure Blob Storage, which will persist the processed results as a file. It can also go to Azure SQL Database or Azure Synapse Analytics or Azure Databricks, used to persist the processed results in a database table for querying and analysis. You can also send the output to Microsoft Power BI, which is used to generate the real-time data visualizations in reports and dashboards. Then we have the real-time log and telemetry analysis with Azure. Data Explorer is a standalone Azure service for efficiently analyzing your data. You can use this service as the output for analyzing large volumes of diverse data from the data sources such as websites, applications, IoT devices, and more. For example, by outputting the Azure Stream Analytics logs to the Azure Data Explorer, you can complement Stream Analytics' low latency alert handling with Data Explorer's deep investigation capabilities. This service is also encapsulated as a runtime in Azure Synapse Analytics, where it is referred to as Azure Synapse Data Explorer, enabling you to build and manage analytical solutions which combine SQL, Spark, and Data Explorer analytics in a single workspace. Data is ingested into Data Explorer through one or more connectors or by writing a minimal amount of code. This enables you to quickly ingest data from a wide variety of data sources, including both static and streaming sources. Data Explorer supports batching and streaming in near real time to optimize data ingestion. The ingested data is supported in tables in a Data Explorer database, where automatic indexing enables high-performance queries. Azure Data Explorer is a great choice of technology when you need to capture and analyze real-time or batch data that includes a time series element, such as log telemetry or values emitted by IoT devices. You can also use it to explore, filter, and aggregate data quickly by using the intuitive and powerful Kusto query language, the KQL. Azure Synapse Data Explorer is an especially good choice when you need to perform these tasks in a centralized environment used for other kinds of analytics, such as SQL and Spark-based queries. All right, demo time. In this demo, we will provision an Azure Stream Analytics job in the Azure subscription, and we'll use it then to process a stream of real-time data. Let's get started. All right, so we are on our Azure portal. This one is going to be an interesting one. Let us look at the bash. So if you're doing this lab or demonstration yourself on the MS Learn, you will get an Azure Cloud Shell on your browser, including the instructions that you need to follow. There is an initial setup which takes a little time, so I've done it already. But let me tell you what the Cloud Shell is and how to use it. So whenever you do it for the first time, it would ask you to create a storage account, a resource group, and a file share. And this is an interactive shell that you get with your Azure portal with Bash and PowerShell CLI, so that you can interact with your Azure services without any authentication. It's a really good one. You should check out if you haven't yet. The initial setup that I'm talking about is this dp900. I have just ran a git clone command. You will find it on the MS Learn. If you look inside, there is a streaming folder where I have all these files set up. In this streaming folder, there is a setup file, this setup.sh file, which I've already run because it takes about 10-15 minutes to go. To save time, I've already set up this file. You just simply have to run a git command saying git clone and the URL, and then come to the streaming directory and run this sh file. That's all you have to do. Now, let me tell you what this script is actually doing. One, it is installing the Azure CLI extensions that we need. Second, it is identifying the Azure resource group provided for this exercise. Third, it is creating an Azure IoT Hub resource. Fourth, it is creating an Azure storage account. 5, it is creating an Azure Stream Analytics job. So all this is automated in this one shell file. Let us look at in the portal. I'll just minimize this for a bit. Let's go to our resource groups. The learn, anything starting with learn should be the resource group that you should identify after setting up that script. If you observe, this is the IoT Hub created, which is used to receive incoming device data. Then you have the storage account, which the data processing results will be written to. And then you have the Stream Analytics job. It starts with stream and a random unique number, which will be used to process the streaming data. So all three of these resources will combinedly work for our stream analytics. The data is coming from IoT, getting stored in the storage account, and is getting streamed by the stream analytics job, right? Let's select the stream analytics job and view the information on its overview page. Now, if you observe, it has one input, which is the IoT hub input, and it has one output, which is the storage blob output. As I said, the input is coming from the IoT hub, getting processed at Stream Analytics, and via that, it is going to the storage account blob, right? Now, let's use these resources to analyze our streaming data. If you observe, there's a start button. This will start the job. And I am going to click on the start right now. Just wait for the notification that the job has run successfully. After the job runs successfully, we'll switch back to the Cloud Shell. There's one more file, it's called iotdevice.sh. This one. iotdevice.sh. I'm just waiting for this thing to get successful, and then we are going to run this file, okay? Perfect. So it has started successfully. Now let's just run this script. What is this script doing? This will start a command to stimulate it is like a simulation experience. It will simulate a device and which will start sending data to the IoT hub. And because it is the input of our Stream Analytics job, it will start receiving all the data, and after processing it, it will send it to the output storage blob. I hope it makes sense. Let this simulation get complete. While this is running, let's just minimize this. We are back to the portal. Let's go back to our resource groups and click on the Learn resource group that is just created for this job. And open the store. This is your storage account. In the data storage, we know where the containers are. Open the data container. In this data container, there is this current year folder, which is having the date and time and the year folder for the hour. So let's just select this JSON file. Select on edit and just review the content of the file. So this is real-time data that is being sent. If you refresh, see, this is 169 rows, refresh, 175 rows. So as soon as we refresh, the data is being sent to this JSON file in our storage container. Let's go back to our resource groups. So we move back to our resource group and let's just look at the Stream Analytics job that's running. And we'll stop it. Just as you will stop it, the data getting ingested in the storage account will stop. And that is a very basic demonstration, a very basic example of how to provide input to a stream analytics job and how to send the output of that data. Now, because we have used a script, you might want to look into the script to understand what is actually written in that and how do you actually automate all these things. So it's up to you. How do you want to explore? Just look up MS Learn. You will get all the important links, the GitHub link as well that I've used here. So yeah, I hope this was helpful. That is all for this demo. This brings us to the end of our module 5 today. We talked about quite a few concepts: batch versus stream analysis, real-time data processing with Azure Stream Analytics, real-time log and telemetry analysis with Azure Data Explorer. This concludes module 5. We will take a quick 10 minutes break and start back with our module 6, explore fundamentals of data visualization. See you then. Welcome back from the break. This is Microsoft Azure Data Fundamentals Virtual Training Day Part 2, and we are approaching a final module of the course, Module 6, Explore Fundamentals of Data Visualization. This module is all about fundamental principles of analytical data modeling and data visualization, using Microsoft Power BI as a platform to explore these principles in action. We are introducing data modeling and visualization. We started the discussion today in Module 4 about the data visualization, which is the last step of our data processing pipeline. Data modeling and visualization is at the heart of business intelligence workloads that are supported by modern data analytics solutions. Essentially, data visualization powers reporting and decision-making that helps organizations succeed. Microsoft Power BI is a suite of tools and services that data analysts can use to build interactive data visualizations for business owners to consume. A typical workflow for creating a data visualization solution starts with Power BI Desktop, a Microsoft Windows application in which you can import data with a wide range of data sources, combine and organize the data from these sources in an analytical data model, and then create reports that contain interactive visualizations of the data. After you've created data models and reports, you can publish them to the Power BI service, which is a cloud service in which reports can be published and interacted with by the business users. You can also do some basic data modeling and report editing directly in the service using a web browser, but the functionality for this is limited compared to the Power BI desktop tool. You can use this service to schedule refreshes of the data sources on which your reports are based and to share those reports with other users. You can also define dashboards and apps that combine related reports in a single, easy-to-consume location. Users can consume these reports, dashboards, and apps in the Power BI service through a web browser or a mobile device by using the Power BI phone app. Let's move on and look at some data modeling concepts. Analytical models here enable you to structure data to support analysis. Models are based on related tables of data and define the numeric values that you want to analyze or report at the entities by which you want to aggregate them. The reports are known as measures, the entities are known as dimensions. For example, a model might include a table containing numeric measures for sales, such as revenue or quantity, and the dimensions for products, customers, and time. This would enable you to aggregate sale measures across one or more dimensions. For example, to identify the total revenue by the customer or total items sold by a product per month. Conceptually, the model forms a multi-dimensional structure which is commonly referred to as a cube, in which any point where the dimensions intersect represents an aggregated measure for those dimensions, while dimension tables represents the entities by which you want to aggregate numeric measures. For example, product or customer. Each entity is represented by a row with a unique key value. The remaining column represents the attributes of the entity. For example, the products have names and categories, and customers have addresses and cities. It's common in most analytical models to include a time dimension so that you can aggregate numeric measures associated with the events over time. The numeric measures that will be aggregated by the various dimensions in the model are stored in fact tables. Each row in a fact table represents a recorded event that has numeric measures associated with it. For example, the sales table on the slide represents sale transactions for individual items, and it includes the numeric values for quantity sold and revenue. This type of schema, where a fact table is related to one or more dimension table, is often referred to as a star schema. Now imagine there are 5 dimensions related to a single fact table. The schema would form a 5-pointed star. You can also define a more complex schema in which these dimension tables are related to additional tables containing more details. For example, you could represent attributes of a product categories in a separate category table that is related only to that product product table. In this case, the design is referred to as a snowflake schema. The schema of fact and dimension tables is used to create an analytical model in which measure aggregations across all dimensions are pre-calculated, making performance of analysis and reporting activities much faster than calculating the aggregations every time. One final thing worth considering about analytical models is the creation of attribute hierarchies that enable you to quickly drill up and down to find aggregated values at different levels in a hierarchical dimension. For example, consider the attributes in the dimension table we have discussed so far. In the product table, you can form a hierarchy in which category might include multiple named products. Similarly, in the customer table, a hierarchy could be formed to represent multiple named customers in each city. Finally, in the timetable, you can form a hierarchy of year, month, and day. The model can be built with pre-aggregated values for each level of hierarchy, enabling you to quickly change the scope of your analysis. For example, by viewing total sales by year and then drilling down to see a more detailed breakdown of total sales by month. You can use Power BI to define an analytical model from tables of data, which can be imported from one or more data sources. You can then use the data modeling interface on the Model tab of the Power BI desktop to define your analytical model by creating relationships between fact and dimension tables, defining hierarchies, setting data types, and display formats for fields in the tables, and managing other properties of your data that help define a rich model for your analysis. After you've created a model, you can use it to generate data visualizations, which can be included in a report. There are many kinds of data visualizations, some commonly used and some more specialized. Power BI includes an extensive set of built-in visualizations, which can be extended with custom and third-party visualizations. This unit discusses some of the most common data visualizations, but is by no means it is a complete list. Tables and text. Tables and texts are often the simplest way to communicate data. Tables are used when numerous related values must be displayed, and individual text values in cards can be a useful way to show important figures or metrics. Then you have bar and column charts. These are a good way to visually compare numerical values for discrete categories. Then you have your line charts, which can also be used to compare categorized values and are useful when you need to examine any trends, often over time. Next, we have pie charts. Pie charts are often used in business reports to visually compare categorized values as a proportion of a total. Also, we have the scatter plot. These are useful when you want to compare two numeric values and identify a relationship or correlation between them. Then last but not the least, we have the maps, which are a great way to visually compare values for different geographic areas and locations. In Power BI, the visual elements in a report are automatically related to one another and provide interactivity. For example, selecting an individual category in one visual element will automatically filter and highlight that category in other related visualizations in the report. Let's move on with trying our hands on to explore data modeling and visualization with Microsoft Power BI. All right. So this would be our last demonstration of the day and an interesting one. So let's get started. For this one, we are visualizing data with Power BI, as you already know. We would need a Power BI desktop installation on our Windows computer. So you can download it and install it for free. I have already done the setup. You can also go and download from https://aka.ms/Power desktop. It's easy, very simple, take a few minutes. And when the file has downloaded, just open it, use that setup wizard, and this is what you will see as the first application interface. It would be similar to what you see right now. So with this screen, we are ready to import the data. What are we going to do in this demonstration is that we will get some data, we'll create some hierarchical spaces, and then we will create different visualizations with all those data. It's simple and it's fun. Let's get started. So the first thing would be to import some data into our Power BI desktop. Let us get data, and in this list of data sources, we'll have to select the web option. Then what you would need is a URL. Where is this URL coming from? We all know MS Learn. So I'm putting it here. It's the customer's CSV file, right? Click OK. This is the data that we are importing. Just to simply click on load. And once the data is loaded, on the right in the field section, you will see the customer data, right? Then similarly, we have two more tables to load, which is our product table and the orders table. So I'll just quickly bring on and repeat my steps. So it is get data, select the web option, give the URL of the product.csv file. Okay, it'll show you the data that you have and click on load. As soon as the changes are applied, you will see the product table in the right side. Similarly, we'll repeat the steps again for our third table, which is orders.csv. So it's the orders table, and we'll simply click on load, and there you go. Easy. So this is importing data in your Power BI desktop. Now these three tables that we have imported, they have been loaded, and we will now look at the data model. Now these three options that you see on the left panel are your most important ones. So model, the data itself, and creating reports. So we'll work with them one by one, starting from the model. Now, because these tables are interrelated, so these are shown as customer product orders, and they're linked to each other with the keys. Now, in this order table, we'll select the revenue, and if you notice the properties, the revenue, enter a description, and we will change the data type to decimal and the format to currency. So this is the revenue is our currency format we needed, right? This will make sure the revenue values are displayed as the currency in our reports. Then unselect it. Now we'll move to our products table. Right click on the table and we'll see the category field. This one. with the category field, what are we going to do here is we are going to create a hierarchy. When you click on create hierarchy, it will create a category hierarchy name. From the product table itself, we'll have this product name and we'll add it to the category hierarchy. You can also rename this category hierarchy as, say, categorized products. We're going to use this again later in the next steps. So this is our categorization that we have created. Now on the left side, if you look at the data option, this is showing us the data of the table selected. Let's look at the customer table. So you have customer ID, name, postal code, city, country, region in this table. Let's select the city, and the data category, name, etc. are city text format. So you can change these things as required. Let's now move on to the other option, which is creating a report. You're almost ready now to create a report because we have already loaded the data, we have seen the data model, we have also seen the data inside the tables, right? As I told you, these three are the most important things that we need to understand here. So let's quickly go to the file, option and settings, and then we click it options, and in the security section, I am going to use the map and filled map visuals. Just make sure this is enabled and then click OK. Why are we doing this? Because we want to include the map visualizations in reports as well. We have seen different types of visualizations in our module. Maps is one of those. So we are including it in reports. So we have to enable it. Now, in this, we'll just move to our next report. So how do you do it? Just simply create a text box, and when you click on the text box, you can change the font. How do you want your data to look like? What size? And all of those things are customizable. Just simply select on any area, and then in the field section, if we expand the product and the categorized products, just simply select this, and this will give us the category and the product name, because we have created a categorization with the category plus the product name. Okay, this is the hierarchy that we have created, so it is showing us only the data that it has. Now with the table still selected, so just as you select and unselect, the things will change here. So with the table still selected, from the field pane, now we want our orders to show the revenue. So if you click the revenue, this same table will be added one more column called the revenue. As soon as you select it from the right fields, it will display in the report that you're trying to generate on the left side. Okay. Now the revenue is formatted as currency. It's in pounds right now. So we didn't really mention any number of decimal places, so it's just giving us a random 363076 and all those details. So you can also mention how much fractions that you want to see, but it wouldn't really matter while creating the visualization that we're going to do right now. Now moving on, whilst in this visualization page, I'll just select a stacked column chart. So the same data that we were seeing as a table, it will now display as the stacked column chart visualization. And it is showing the revenue and the categories on the X and Y axis respectively. Now, if you click on these arrows, so if you want to drill down, if you select, it will simply start drilling down and see the revenue of the individual products in the specific category. If you unselect it and drill up, it'll again become the normal one that we were earlier seeing, right? So you can select, unselect, drill up and drill down on what you want to see. Now select any blank area, and then from the fields, just select the quantity from the orders table, this one, right? And now this is the category field. This is another visualization that we're trying to create. Now this products has a category field. This is showing us what category is having what quantity. Now this is a visualization of category by the quantity. You can also change this visualization to, say, a pie chart. So it will start displaying with the number of and the percentage of the touring bikes, jerseys, road bikes, mountain bikes, depending upon the category of the product and the quantity. It has created a pie chart. Now, this is all really customizable. So if you want to see the road bikes, it'll highlight. So these are all interrelated. If you want to select the mountain frames, it'll highlight in this one. So similarly, if you look at the pattern here, it'll reflect on the left side. So it's a very interesting thing to explore. I would really recommend doing this practice by yourself. Moving on, will be on the blank area now. So we have two visualizations already. We'll go back to our fields. In the customer table, if you remember, we had the city, right? Because we have enabled the map, we want to see a geographical view. Now this map is also very customizable. And if we select the revenue here, it will start showing which area has the most revenue in this map. So you can resize it, the map. You can scroll it up and down. You can zoom out, zoom in, and look at the areas that are showing. So it's that flexible. Now, with this, you can select the fields, create and build these visualizations and create a dashboard. And now if you want to save it for your future references, just simply go to File, click on Save As, and just give a name saying Products Visualization. Power BI file, which is the .pbix extension, and simply save it. So you can anytime open this dashboard, change some fields, look at the dashboard, how are things behaving, which products is getting more revenue in what area, and all of those analysis can be made from reports. So yeah, that was all that we had to cover in this module. I hope you enjoyed it. Let's move on. Perfect. That brings us to the end of module 6, which was our last module, hence concluding our course on Azure Data Fundamentals. This was part 2, and now we'll recap what we have seen so far today. We started off with understanding large-scale data warehousing. We understood the data ingestion process through ETL and ELT, denormalizing relational data in the analytical data stores, data modeling in cubes to data visualization. Then we discussed data ingestion pipelines with types of analytical data stores and how you can choose the best data store for yourself. Then we provisioned Azure Synapse Analytics Workspace and used it to ingest and query data. Then module 5 was quite a few concepts, batch versus stream analysis, real-time data processing with Azure Stream Analytics, and real-time log and telemetry analysis with the Azure Data Explorer, and a demo on Azure Stream Analytics. We created a job in the Azure subscription, streaming real-time data. Then we ended our last module 6, talking about data modeling and visualizations with Power BI. We understood analytical data modeling and saw some common data visualizations in reports. We ended with our hands dirty with the Power BI desktop, making some visualizations. A lot of concepts, a lot of fun. I hope you enjoyed it as much as I did. I thank you all for attending the Microsoft Security Virtual Training Days, Azure Data Fundamentals. Remember, there are many ways to continue your learning journey, such as MS Learn, where we offer self-paced learning options, including labs. Happy studying!